Hi everyone, I'm Niveta, a final year student pursuing Bachelor of Engineering in Computer Science. Today, I'm going to present my project titled EcoTrace Cloud, a carbon-aware supply chain optimization system. The main objective of this project is to reduce a carbon emission in cloud-based supply chain operations using machine learning and carbon-aware task scheduling techniques. Nowadays, cloud computing and supply chain systems consume large amounts of energy, which increases carbon emissions. Most existing systems focus mainly on performance and cost optimization, but they do not consider environmental sustainability as well. So, our project introduces a lightweight and intelligent framework that predicts carbon emission and schedules tasks in a more eco-friendly manner. In this project, we developed a carbon-aware optimization framework for cloud-based supply chain systems. First, workload data is generated and stored. Then, machine learning models are used to predict the data based on workload parameters like CPU usage and execution time. After prediction, a carbon-aware scheduling algorithm allocates tasks efficiently to reduce overall carbon emissions. Finally, the system compares emission before and after optimization, then displays the results using dashboards. Then comes the problem statement here. Existing cloud system mainly focuses on faster execution, cost optimization, and high performance, but they ignore carbon emissions, energy consumption, and environmental sustainability. Also, many existing technologies they mainly focus on carbon monitoring systems, depend on IoT and complex infrastructures, which increases implementation cost. So our project provides a lightweight and intelligent solution without depending heavily on IoT infrastructure. So the key concept used in the project is carbon-aware computing. In traditional cloud system, tasks are scheduled based only on performance, but in carbon-aware scheduling, decisions are made based on carbon emission levels also. A system predicts carbon emission before execution and schedule tasks in a way that reduces environmental impact while maintaining acceptable performance. So these are some of the literature reviews that I have researched related to cloud computing. So we analyzed multiple research papers related to green cloud computing, energy efficient scheduling, carbon-aware optimization, sustainable supply chain systems. From the literature survey, we identified that existing systems mainly focus on performance. Few systems considered carbon emissions. Most approaches are computationally complex. Based on these research gaps, we proposed a system. And here comes the issues and challenges. During the development of this project, several challenges were introduced. Predicting carbon emissions accurately, balancing performance and sustainability, designing lightweight ML models, managing cloud workload efficiently, lack of real-time carbon data. These challenges motivated us to create an optimized and practical solution. And this is a proposed work, and here comes the architecture diagram. So there are six modules. The first module is like workload simulation module. This module generates simulated workloads like inventory updates, logistic processing, and order tracking. It creates workload parameters such as CPU usage, execution time, and memory usage. The second module is the data management module. The generated data is stored in CSV format. Pre-processing techniques like cleaning and feature selection are performed before training the ML model. Third comes the carbon estimation module. In this module, machine learning models are used to predict carbon emissions. Input features like CPU usage, execution time, and workload types are used. The system predicts emission levels as low, medium, and high. We use random forest technique here for prediction. And fourth comes the carbon-aware scheduling module. After prediction, tasks are scheduled using a greedy-based optimization strategy. Tasks with lower carbon emissions are prioritized first. High emission tasks may be delayed or rescheduled to reduce overall carbon footprint. We use greedy algorithm because it is lightweight, faster, and suitable for real-time scheduling decisions as well. Fifth comes the sustainability evaluation model. We compare emissions before and after optimization and calculate carbon reduction percentage. This helps us measure how effectively the system reduces carbon emission. Finally, reporting and visualization module. Dashboards and graphs are generated to visualize predicted emissions, task categories, carbon reduction percentage, optimization results. It also shows us the compares it also compares before versus after results, visualizes reduction in performance metrics, and generate dashboards and reports for decision support. And these are some of the tools that I have used for this project. For front end, we use React backend, Python, and ML we use, and database like MySQL, and tools I have used VS Code as well. And these are the each modules and this description, which I have already explained by seeing the architecture diagram. And this is the implementation screenshots of the project, and this is the code. So this is the dashboard. So in this dashboard, we can see the live dashboard preview as total predicted carbon values to 18.22 and reduction percentage and optimized as well. And I also mentioned the some of the module pipeline overflow like train module prediction emissions, decision engine scheduler and evaluation as well. So this is the first module where we can see the global filters and decision filters and region-based filters as well. We can also save the views and reuse it later as well. This is the graph which shows before versus after optimization based on the decision region priority filters. Then comes the second module like optimization insights, where we can apply filters and see the graph based on the filters. So as I said before, I have also mentioned the saved views here. So let's say that I particularly need some region like AP East and decision as execute immediately and priority is low. I will save this and reuse it later whenever I need it. In pipeline operations, I have given two modes, which is demo mode and real mode. In demo mode, I will be already updated the I will already update the data set and it will show the output. In real mode, we can directly update the data set by uploading the data set and it will go step by step as I've mentioned in the architecture diagram. So it will also show after uploading, it will also show like upload successful. It will also show how much rows it has been validated. These are the step by step process. And these are some of the references that I have taken for this project. And this is the SDG goal, which is related to my project, which is SDG 13 climate action, which reduces carbon emission from cloud-based supply chain operations and also encourages environmentally responsible cloud resource allocation. And I've also and my project is also related to SDG 12, which is responsible consumption and production, optimizes cloud resource usage efficiently, also support green computing practices. I will give the demo of the project, and this is the project that I have been implemented. So I'll just give you a walkthrough of it. So firstly, I'll try to run the project. So I'll try to run the backend first, cd backend. So I'll go to the current directory, then I'll run the code now. Side by side, I will also run the front end as well. So here I'll give a cd front end and I'll run and I'll give us npm run dev. So now it will be running on this local host So I'll try to copy and paste it here. So this is the dashboard of the project that have been created. So here you can see the Carbon Optimizer platform mentioning the how I have introduced and how I have created it. These are the graph of the data sets which I have uploaded. So it shows the total predicted value reduction percentage and optimized value as well. And these are some of the explanations of each module. As well as I also showed the pipeline flow here, train model, prediction happens, then decision happens, then scheduling, and finally evaluation. So when I give open dashboard, it will be redirected to a new page where we can see all the modules here: executive, overview, optimization insights, operation explorer, explainability AI, and pipeline ops. So firstly, we can see the executive overview here. So these are the things that I have already mentioned in the project where I will be able to see total predicted value, optimized value, reduction percentage, and average of the task. So these are the global filters here. It is done by AntLogic. So decisions, let's say that I have to execute immediately in AP South. So these are the various graphs denoted with the help of the filters. Also, if I want to clear, I can clear this. Let's say that I need green region immediate at US East, and I have to download this view particularly. So I can give download. So it will be downloaded, and we can also use it in local as well. So it will download all the entire flow, like you can see how it has been running through it. And if I try to open this in downloads, I can see the downloaded PDF here. So when I try to open this, we can see the entire implementations. See, these are entire modules one by one. It will be showing and it will be downloaded. So yeah, so coming back to a project, if I don't need this filter, I can give clear filters as well. So let's say that I want to save the current filter, like schedule night, US East, and I need this filter, so I'll give as current filter and I'll save it. If I save it and if I give clear filters, if I give a shift to green region AP South, it will be moving to another filter based on the global filters. Let's say that I need the previous view. So we can go directly to the current filter view and we can see it has been automatically changed to the saved view. So we can clear filter. If we want, we can also give delete filters as well. So these are the before versus after optimization graphs. And these are the carbon based on the regions after optimization. So we can also see the units denoted by it. And in optimization insights, we can see the difference between before and after optimization and also the graph here. In Explorer, we can see the task trends like before and after, where the green region represents the after optimization, orange represents the before optimization as well. Explainability AI is a module where it's like a summary which is written by the AI. So you can see filtered workload reduces carbon by the percentage of 25.2, and we can also get the insights from it and recommended actions accordingly. And finally comes the pipeline ops. So in demo mode is a mode where we upload the task using code, and real mode is something that we upload from the local files. So let's say that I'm going to choose a file here and I'm going to give the carbon scheduling dataset first. If I give open and it will be uploaded here, so I have to click upload workload CSV So it has been showed upload successful, 12,000 rows were affected. And when I give run pipeline, it will start running. It will take some time to run the whole module and give us an output. So now we can see the difference of the data sets here. We click on home. I can see the total predicted value, reduction percentage, and optimize are different compared to the previous dataset because this is a new dataset that have been uploaded. So we can also choose file and upload the dataset for the future use as well. So it also says pipeline executed successful in real mode. So yeah, I hope this project will create something that will be useful for the environment and supports green computing as well. Thank you, everyone.